Hello and welcome back to the Diabolo tutorial series. I'm Michael, and this time around we will create a camera system and we will move our character. Okay, the first thing we want to do is to download the video description download link, and we want to download the Tut Asset 3 RAR. Just extract it where you want and import the cursed Reticule TGA into our editor. Now we wait a little bit and we save all. Okay. Right click on our cursed Reticule and create material. We double click on our newly created cursed Reticule material and we end up in our material editor. This time around we need to change something, because we want the reticule to appear on our screen, but not as a world object, but more of an overlay object. And for overlay objects and HUDs in general, we will use the widget class. And the widget class is actually for overlays. Now, we need to set it up so we can actually use this material. And we do so by converting it into a user interface material. Just go onto the left panel under material domain and select user interface. Under blend mode, we will use the option masked. Now we will use the mask feature to actually mask out unneeded texture bits we don't want. We want to be able to have some parts of our texture invisible. So just select this pin and connect it with the final color, and select this gray pin and connect it with the opacity mask. We have here a diffuse texture, and in our diffuse texture we also have an alpha channel. And this alpha channel is basically responsible for what will be visible of the texture and what not. Just save it and wait a little bit. Hopefully it doesn't take that much time. Yeah, okay, it's done. Now the next thing we want to do is to go into our Diabolo car blueprint and go under viewport and select a camera. So first we need to add a spring arm component. The spring arm component basically is a cool thing because it can smoothly transition between camera movement. So we don't get this harsh transition of our camera. We can actually smooth it out. So compile it and save it, and on the right properties panel we will set the target arm length to 1000. Compile and save. That's basically the length of the offset of our spring arm. Now we go down to the lag tab and enable camera lag and enable camera rotation lag. We will put the camera lag speed on 8 and the camera rotation lag speed on 8. The lower the values, the higher the smoothing value will be, but don't put in a too low number, because it will then transition very slowly and it might defocus your character. So keep that in mind. Compile it and save it. Now we need to add another component. You can either do it by deselecting all things here and type in camera, but we want to have it as apparent in the spring arm. You can either do it by dragging the camera onto the spring arm, or you can select the spring arm, go to add component and then type in camera. It will then automatically be a child of the spring arm, so it will be directly attached to the spring arm. We will delete our leftover camera, compile and save. Now we need to position it in the right way to an isometric view. So select our spring arm, then press E or press this button up here, the middle button, and rotate along the y-axis, this green axis here. So around -90. Then rotate on the red x-axis, but on the positive, like 40 degrees. No. We will get the other way around. So we will rotate it to -40 degrees. So we get this isometric view from this side. And then we will rotate along the green y-axis like 20. Compile it and save it. If you want to translate something here or move something, you can press the W key or press this button here. Or if you want to scale something in here, press the R key or press this key here. Okay, we are done here. Save it, close it, and go under Edit. Under Edit, select Project Settings. It will take a little while. And under Engine here, select the User Interface tab. And under Default Cursors, or Default Cursor, we will select our widget, which is weirdly not in the list, because we didn't create any widget right now. So we should do it. Right click here, select User Interface, and select Widget Blueprint. We will call it the Reticule widget. Double click on it, and we will basically get into the widget editor. And this widget blueprint is actually the overlay blueprint, where we can create HUDs, custom information, even pop-up behavior like pop-up comments and such. So this is kind of the overlay feature of our of Unreal Engine. Go on the left panel under Common and drag in the image. Now go on the anchors here, select it, and take the middle one. This will basically tell our widget that this image here should be centered in this position. This is important because if you change your resolution, your image might end up over all the places. So it can end up in a place you don't want it to be. So always keep in mind, select this or this or this, just that you have an anchor of some sorts where the image will be displayed at all times at every resolution. And we will take the middle one. Now select our image, go under the brush here, and select on the image our newly created curved reticule matte. It's kind of stretched, so we will fix it. Just take one of these points and scale it to the right size. We will disable the snapping feature up here, so we can better align it to our flower-like anchor. So drag it on top of it, so it's kind of centered. This should do. And compile and save it. And we are done here for the first bit. Close it. And now we go under Edit and then under Project Settings. Now we go again under Engine to the User Interface. And under Default Cursor, we can select our Reticule widget, Wonderful. So we do that, close the project settings, and we go on to the next part. We need to set our cursor actually to be shown at all times, and we do that in the player controller. So double click on the El Diabolo PC, open the full blueprint editor, and on the right side search for something called show mouse cursor. You can also select enable click events, and on the default mouse cursor should be the setting default, because it will use our widget we specified in our project settings. Compile it and save it. But we are not done here. We want to have movement functionality, and we do that in the player controller. So we will first right click, then search for the button called left mouse button, and we will search our event tick here. We will use this here. So right click again, type in gate, and connect the event tick to the enter of the gate. Now our event tick will be enabled in the player controller. Now select the left mouse button, or use the pressed button here, and connect the pin with the open pin and the released pin with the close pin. Compile and save. This here will basically run through our gate or our gate node. It will not pass in any information after the exit node. But if we press the left mouse button, it will open the gate and it will pass on our game logic on the exit chain here, and it will basically be translated into our game mechanics, which we run after the exit here. So the next thing we want to do is something called get hit result under cursor by channel. This will basically check what we clicked on and on which position or location we clicked on. So just drag out from the get hit result pin, break hit result, and we will get this very fancy looking node. We will use it for certain things like getting the specific goal and such things. So the next thing we need to add here is actually some kind of logic. So we right click and type in get controlled pawn. So this will basically get our character blueprint we are using. Drag out from the return value and type in I lost my train of thought here. Get controlled pawn. And I think it was velocity we needed. Here, get velocity. No, sorry. Delete the get velocity, we need the actor location. So get actor location. Okay. Now, when we hit something with our mouse cursor, a terrain or anything like that, we will get the hit result of this. So we want to get the impact point here. We can also use the location, so we might even use the location. And we want to subtract it with the get actor location. So we get actually the length between our get actor location and the impact point. Now we should disconnect them, and the get actor location should be in the first value and the location should be in the second value. Now we drag out from the result yellow pin and we type in length. We want to get the length between the get actor location and the location we clicked on. So we can kind of get our something out of it, a certain value to drive our movement. So the next thing we want to add is add movement. But well, it's not in here because it's a pawn node. So we drag out from the get control pawn, input add movement input, and here it is. Now the next thing is we want to kind of check against the minimum click distance, and that means if we are too close to our character, it will not fire off, and that's just for performance reasons. So we add a new variable called minimum click distance. We will get onto the right panel and select float. The minimum clicks distance will be around 128 because it works for me, and it's it is basically a working number. You can input what you want here. You can increase or decrease it, and then after the exit, drag out from the exit pin and type in if. Drag it into the add movement input, and we want to check against our minimum click distance. So drag out from the vector length and type in is greater, and then is float greater or equal than float. We drag in our minimum click distance, get the get value, and put it into our 0 value here. We connect the red pin with our condition pin and our true pin to the add movement input. So if the click distance is too small, we will not move and we will not execute our add movement input. So there's one thing we also need to consider. We have something here like world direction and scale value. The scale value, you can input here the vector length, and our world direction will be calculated by something called get distance to, or get distance vector. So right click, or select distance. Wait a second. Distance. Get point by distance. No, that's not the right one. Maybe it's on the pawn. Distance. Get distance to. So drag out from the blue pin from the get control pawn. Type in get distance to. No, that's the wrong one too. We need the distance vector. But why don't we get it here? Right click, distance. Maybe with a context. That sometimes happens when they change things. There should be something. I'm inputting distance. I'm an idiot. Sorry for that. I am an idiot. We need the direction. Direction vector. Yeah. Okay, sorry for that. They renamed this vector here. So it's called get unit direction vector. Before, in I think my prototype, it was called direction vector. So yeah, sorry for the confusion. Just right click, type in get direction vector, get unit direction vector, and you will get it. From will be from our get actor location, and the to will be from our location we hit. And then the return value will be connected to the world direction of our add movement input. Compile it and save it, and we should be good to go. This method has the advantage of not using an navigation mesh. So that's pretty cool. Save it, and remember to open your test level, because we already selected our game mode over right here, and click play. Now we have our fine reticule here. Left click, and it will kind of move. The problem is the character doesn't really turn into the right direction. So we escape. I forgot to check two boxes, two very important boxes for the hack and slash game here. Double click on the El Diablo car blueprint, go to the character movement component, and search for orient. We want to tick the orient rotation to movement. And what this basically does is that it will always rotate our character blueprint into the direction we are clicking into. So it will always follow our cursor. The next thing we want to change is go to the El Diablo car blueprint, or the self one, and delete it from the search here, this orient, and search for use controller rotation yaw. Deselect this. Right now we are using the controller rotation, but we want to use the pawn or the character blueprint rotation. And we are also basing our unit vector on our character blueprint. So this needs to be unchecked. So compile it and save it. Play, and you will notice, it works, kind of. But why is the camera rotating with the actor? This shouldn't be. That's not in Diablo or Torchlight or anything similar. So we go out of our standalone or of our preview. We double click on our El Diablo car blueprint, go to our spring arm, and change here on the arrow here on the transform on the rotation to world, which creates an absolute rotation. This way our spring arm will not take our character into account or our character blueprint rotation into account, but will be independently rotated in world coordinates and having an absolute rotation. So if we play right now, we have the right functionality and it works perfectly. So yeah, I will see you in the next part, hopefully. I wish you a wonderful day, weekend, evening, or whatever.